Hey everybody, welcome to today's Kubernetes Masterclass. Really happy to have you all joining us today. Kind of as usual, we have just a massive number of people who are interested in this topic, and there is a lot to go over. So we're gonna dive right in here. But while we're just at the beginning, I want you all to know that this session is being recorded, and you will get the recording and the slides after the training. We're talking about understanding and implementing service mesh today, and there's a lot to go over, so let's jump on in. As a way of introduction, my name is Matthew Shear, marketing manager here at Rancher. I help put on these advanced trainings and our intro trainings as well, which I'll talk about a little bit more as we go. Please use me as like a point of contact, a resource at Rancher. I'll do my absolute best to respond to everybody. You can reach me on the Rancher user Slack, which I'll also talk about in a moment. A little bit more, and on email, so don't hesitate to reach out. But the man who's really going to be doing the heavy lifting today is Eamon, field engineer here at Rancher. Eamon, are you on the line? Are you there?
I think I'm here. Good morning, everyone.
All right, awesome. Well, I'll let Eamon introduce himself a little bit more as we go. I also want to give a big shout out to a couple other engineers who stepped up to help us out, Jason and Sheldon, because we have a lot of people on, and we want to absolutely be responsive to everyone's questions and make sure that you all get what you came here for. So on that note, we have about 75 minutes scheduled. We might go a little bit long if needed because you might have questions or for whatever reason. Again, this is meant to be responsive to what you all want to learn. So please do put your questions in the chat. Ask the questions that you do have. We just ask that you keep them to the best of your ability, sort of on topic. If for whatever reason they're a little bit outside the scope of the training, then we might refer you to another resource. We do have fantastic docs, other training sessions, and things like that that we can point you to. GoToWebinar has a really cool chat feature, so just put your questions into that tab and we will get to them as we are able to. We'll also have a lot of time scheduled at the end to just answer all the questions aloud for everybody's benefit. So on that note, if for whatever reason you want your question to be private, just let us know. Otherwise, we will answer it aloud for everyone's benefit because this is educational. As I said at the beginning, the session is being recorded. We put all of our sessions, all of our trainings on YouTube, so you can check them out there on the Rancher YouTube's channel. We have trainings that go back, a couple years. We put our online meetups and our intro trainings there, so there is just a ton of learning available. And as I mentioned, there is a Slack channel just for these master classes where we can post slides or answer some additional questions later on. But Rancher user Slack is a huge community. There are thousands of members and hundreds of people asking and answering questions every day. Our engineers are on there as well. So if you're not part of the community, I think many of the people here already are. But if you're not, I highly recommend joining and asking your questions there and just getting plugged in. And finally, there are a lot of other fantastic classes coming up. Our monthly online meetup is next week, which should be super exciting because we just dropped Rancher 2.4, and it has a ton of awesome features. A lot of stuff is going on there, and Shannon Williams, who is the president and co-founder of Rancher, and Darren Shepard, who's the chief technology officer, are going to be leading that one. So it's going to be super interesting. A lot of engineers will be on there asking and answering questions as well. And then we have a masterclass the following week, and I also put here the intro to Rancher and Kubernetes training, which happens every week. So please do check that out. If you are new to Kubernetes, if you're new to Rancher, if you want to understand, how Kubernetes works, architecture, components, things like that, that is a fantastic resource, and it is free and happens every Thursday. So again, I'm going to turn this over to Eamon, and just remember that if you do have questions, please do put them in the chat. We have some engineers who might help answer there, and we'll take a couple pauses during the presentation and mainly at the very end to answer your questions. So without further ado, Eamon, I'm going to pass this off to you and make you. So let's see here.
All right, let me go ahead and share. All right, perfect. Do we have my screen?
Yep, you're good to go.
Excellent. So thank you for the introduction, Matt, and getting everything set up and set the stage there. My name is Eamon Bauman. I'm a field engineer here at Rancher Labs, and today we're going to go through understanding and implementing service mesh. So jumping right in, without too much talking to do here, understanding service mesh. We've got an agenda here. The first thing we're going to do, actually, it's right in the title of the presentation, is to understand service mesh. Talk about what it is, why we may need it in certain situations, what problems a service mesh solves, things like that. We're going to go over some basic service mesh concepts. As probably most of the audience knows, there are a large number of service meshes out there, so I'm going to try and touch on points that are common to all, or at least most, service meshes. Specifically, Istio is the one that we're going to spend a bunch of time with today, because that's the one that the Rancher 2.3 product, and we're now on 2.4, so it's been out there for a little while now. That's what the Rancher product integrates, is Istio. During our demo, we're actually going to set up and configure Istio using Rancher. So we will walk through live and unscripted an installation of Istio into a Rancher provision Kubernetes cluster. We'll do a bunch of setup and talk about how the integrations work within Rancher. And then I've got some final points and wrap up, some next steps and things to talk about there. So jumping in, let's understand service mesh. We're going to go through a brief timeline here. So if we put on our, Dolby surround sound theater voice, in the beginning, there were monolithic applications. And then there's a big picture of this giant monolith and the weird little people down in the corner who I'm assuming have now discovered this magic monolith. But unfortunately, to their demise, the monolith runs on Java. No, I'm kidding. Java's a perfectly fine language. Had to drop in the joke there anyways. Monolithic applications. So whenever I think of a monolith, I always kind of think of the Washington Monument, honestly. I always think of well, I mean, there's the picture right there on the previous slide, right? This giant sort of towering thing of stone rising up into the clouds, right? So I always think of the Washington Monument. In software engineering, though, a monolith is and this is a quote from Wikipedia, just so you know, I did my absolute best high school research here. A monolith is a single-tiered software application in which the user interface and data access code are combined into a single program from a single platform. In typical Wikipedia fashion, that is a long explanation with a lot of words to it. I'm a much simpler person than that, so it's an all-in-one piece of software. A monolithic application is one code base for everything in your app. So the user interface, the data access layer, the data store itself, and sometimes you can get a little fungible with those concepts. So it may be not that there's a user interface because you may have like a web application, for instance, right? And your backend side of that web application has the business logic and the data access layer that in itself is a monolith, even though the user interface is separate, right? So a monolith is a single tiered software application, or like a 1 to 2 tier, I guess, is kind of what I'm going to add as a wishy-washy bit of definition there. There's a great link that Chris Nova put together back in the original Heptio days before they were acquired by VMware. And this blog post has an awesome what is a monolithic application diagram and explanation that shows you how different pieces fit together into a monolith so you can kind of understand exactly what that monolithic thing is. Now, this is how folks have written applications for years and years and years and years and years and decades and for so on, until the beginning of time, right? That we have built traditionally applications to be all part of one cohesive unit, one stack, one, however you want to describe the collection of those things. So if we've done that, and if we've been building our applications that way for so long, what's the problem? Well, it turns out the problem kind of depends on who you ask. So issues with monolithic applications become apparent typically as the application, and I don't have it here in notes, or as the organization scales. So you're really going to start to see issues when you're scaling up a monolithic application, and typically these issues arise if the monolith isn't prepared for that scaling or isn't capable of it natively. The first point really is vertical versus horizontal scaling. So if we've set up our application to be a monolith, a lot of those monolithic applications are not set up to be scaled horizontally. Vertically then is usually the first option that organizations take when we start talking about scaling a monolith. So instead of adding more instances of this monolithic application, we're going to toss more resources at the server or at whatever is running this monolith, right? So we're going to scale up CPU, we're going to scale up memory, maybe we'll add more bandwidth for traffic to that single node, but we're still scaling a single instance of the monolith, because a lot of those are not prepared to be scaled horizontally, right? Horizontal scaling often requires changes to the application to make it horizontally aware. The reason I say that is that a lot of monolithic applications are not stateless. Horizontal scaling and Kubernetes, if you're familiar, and if you're looking at service mesh, probably you are a lot of those applications that are stateless are very easy to horizontally scale. There's no state that needs to be shared amongst the different instances. I can scale out 1, 2, 3, 500 n instances of my application to get the scale that I need, because I don't typically need to share that state between the instances. Monolithic applications, and sometimes you can also include a legacy definition in there as well, are not horizontally scaling aware. Scaling vertically then is the best and usually the first option organizations take, but you hit a limit where it starts to get expensive or may not solve the problems you need, where adding more resources to the single instance may not be feasible because of some other constraints, like you're hitting a bottleneck at the database, or you're hitting a bottleneck in the number of threads and there's no more CPU you can add, right? Where you have to horizontally scale. So that's one issue. Another issue you may run into is deployment velocity. So as monoliths are getting bigger, and remember that all these issues are as the application scales. So as your monolith is getting bigger, your time to release for features can slow down. And that can be an issue for an organization, where if you are expected to be nimble with this application and respond to changing market trends, which sounds like such a marketing thing, you're going to have challenges with that as the monolith gets bigger. Some of these challenges are technical, right? Like it could be a compile time where your application, because of its size and because of its code base, takes 30 or 40 minutes to compile a full set of the application. That's possible, but oftentimes it can be organizational policies in play too, where any changes to the application require a full change control board review, require a sprint to be set up, and all these things where your velocity is sort of dampened when you're trying to be nimble with new feature deployment, because the organization has put different things in place, and rightfully so, with the scale that you're seeing. Another issue as the application scales is a choice of tooling. So a monolith, almost by definition, is built on a single technology. So we had in our picture there just before the Java logo, a Java EE application, it could be a .NET application, could be C++, whole bunch of different things. But almost by definition, your monolith is going to be built on that single technology. The challenge there is that there's only one tool set to lean on. It's also a strength because then there's only one tool set to learn, but if you remove that R, there's only one tool set to lean on. So you can't use the right tool for the job. Where if you have a new feature you want to add or have some sort of optimization you want to do that some other language or some other technology may be well versed for, you have to sort of wedge that in using whatever technology your monolith is built in. So that can be a real challenge. And the final point is developer understanding. So really just this can be summarized as the bigger the application, the more difficult it is to grasp. So grasping the entire application is something that can be necessary, especially as developer gets up to speed and they want to start making changes, but they don't understand how those changes are going to impact other areas of the application. And the bigger the monolith gets, the more difficult it's going to be to ramp up developers in order to be productive and understand all areas of that application. It may even be impossible at some point where you just have to start limiting the amount of impact that new developers can have on your application. So that's one of the challenges, or actually really four of the challenges with monolithic applications. And again, these all become apparent as the application or the organization scales. What I'm going to introduce to you now is a sample monolithic application. And the reason I'm doing it here is because this is going to help illustrate what we're talking about when it comes to microservices and how we're going to break up a monolith and how some of this is going to impact the service mesh discussion we're having later. So our first application that we're introducing, this monolithic application, is a book information application. Now, if you've ever messed around with Istio or deployed it or done anything like that, this is probably pretty familiar. But in case you haven't, BookInfo is the Istio introduction basically to service mesh. So what I've done here is sort of abuse that example and turned it into our monolithic application. The BookInfo app has several components, the first of which is a product page. The product page is the user interface that grabs information from a bunch of different data sources. Those data sources are detail data. I should back up and explain. Book information is a simple application that shows a review and ratings of a book. So if you go in your web browser and you open up the product page, I get to see the name of a book, its author, its ISBN number, all that kind of stuff. I get to see details about the book. I get to see reviews and ratings about the book. That's our example application. So all of those pieces of functionality are brought into our monolith here. So I have the book info with its product page. I have detailed data, so the product page will pull in details about the book, like the author and the ISBN number and stuff. The product page will pull in information from review data. So how did someone like this book? They've given it a review. We can view that information in the UI. And then finally, ratings data. So if a user leaves a rating, how many stars out of 5 did a particular book get? So again, we're displaying information about the books. This is the data access and logic layer for getting details about our book. This is data access and logic layer for getting reviews about the book. And this is data access and logic layer for ratings about the book. So let's talk microservices. We have our sample application in mind. I'll back up one last slide. We have our sample monolithic application in mind. So let's talk about microservices and why they may make sense. The goal of microservices is to build an application as a suite of services, hence the name microservices. Services are independently, deployable and scalable. The goal being that in a microservice architecture, each service, because the services are separate, is going to form a boundary with the other services. That boundary is typically the form of an API that each service offers. So typically, though not always, services are accompanied by an independent code base. Sometimes you can do a mono code base, a monolithic code base, I think is what they refer to it as. But typically, there are separate code bases for these microservices. The process of converting a monolith to a set of microservices is called, quote, breaking up the monolith. With a suite of microservices, what we're really doing is taking the different functions of what was a monolithic application, distributing them amongst tiny little applications. I mean, each one itself, you could consider it if it was a full application to be a monolith, but really it's just a component of a distributed application. Now, each one of these services then is going to offer, well, a service or a function, right? The boundary that's formed with the other services, or rather the contract that's executed between these services, is typically the form of an API. So that could be a REST API, we may be talking gRPC, something like that. But the services are meant to, almost by definition of microservices, to act independently of each other. So let's take a look at what splitting up this monolith would look like. So we have our book information monolith over here. I've got the product page, detail, review, and ratings data on the left, all as components of this application. If we split this up, we're going to move the product page out into its own components. We may take that set of functionality for the user interface, split it into its own code base, and then offer it as an API. Maybe this is just the browser arriving at this UI, and the UI will make other API calls to other microservices. Well, by doing so and by moving this component out of that monolith, we've built our first microservice, which is the product page. Let's take our business logic and our data access layer for book detail information. We'll move that out into its own code base. Now the product page is going to be able to query for information about books from that detailed data microservice. So then we've built our second microservice. We'll do the same thing with review data. We'll move it out into its own code base and we'll build a microservice around it. Same with ratings data, out into its own code base, and now we have a microservice built around it. So what we've done here is we've taken our monolith and we've taken the different areas of functionality in this monolith, we've moved them out into their own code bases. And again, That's typically what you do, but you can have one code base and deploy microservices from them. It is an option. But we've moved all of these out into their own instances and created microservices from them. Thus, our book information application ceases to be that monolith on the left and actually is the collection of all of these microservices. So now we have a distributed application where each one of these microservices can be independently deployed, distributed, built, scaled. They all have their own velocity of deployment. I'm kind of searching for different examples to tie into, right? So if I go, let's step back here a bunch of slides. Now that we have, there are a lot of animations to slide back through. Here we go. So now if we have each one of these feature sets in its own bucket, a bucket being its microservice, now our vertical and horizontal scaling issue is solved because we can take one instance of that microservice and horizontally scale it out, or vertically scale each one of those instances, so we have easier ability to scale that piece of functionality of our application. Our deployment velocity is accelerated because now areas of functionality can be rapidly iterated on without necessarily impacting other areas of the application. Where if we're going to do work, now let me slide over here, if we're going to do work, come on, just on like the ratings data section here, if that's split out into a microservice, we're not going to affect review data or detail data or the project page by making changes to that microservice. So we've sort of insulated different areas of the application from changes from one another, so long as we adhere to that contract or that API that we have as a boundary between the microservices, then we're safe. Our choice of tooling now is open. So if we have our areas of the application split out into microservices, I can write one piece of functionality in Python, I can write one piece of functionality in .NET, I can write another in Golang, whatever works best for that specific approach. We've also now aided developer understanding because a developer may want to know sort of abstractly how the entire application fits together, but concretely they only need to know the microservice that they're working on. And you can now accelerate a developer's, I guess, mean time to production, if you will, or mean time to productivity by allowing them to just have that abstract concept of how the application fits together, but the concrete knowledge can be slowly introduced through allowing them to work on different microservices, and they can remain productive even if they only have sort of a brief understanding of the application as a whole. So let's jump ahead back. So we split up our monolith, got our different microservices here. So if we've got all these microservices, where does a service mesh come in? Or, quote, why do I need this thing? This slide and what we've gone through so far have been, okay, monoliths are great. What's the problem with them? Why do I need microservices? Service mesh, why do I need that if I have microservices? If microservices are an approach to solving monolith problems at scale, a service mesh then is an approach to solving microservice issues at scale. One of the microservice issues we're going to run into is routing and terminating traffic. So as we distribute different areas of our application into microservices, we need to make routing decisions across things like versions, for instance, or if I'm deploying different versions of a microservice, maybe my details version has v1, v2, v3, v whatever, I'm going to need a way to make routing decisions across different versions of that microservice, because maybe some of my clients still need to use v1 functionality. Maybe we want to do, sort of a sample deployment of v2 functionality. I need to make those determinations based on different criteria. We also may need to terminate different things like TLS certificates. So what happens if my microservices are expected to be hosted for different tenants? Maybe I need to do TLS termination across different host names. So that's another option. We also may want to enable features like weighted deployments, canary, blue-green deploying, things like that. We need a way to be able to split, separate, and route that traffic between our different microservices. Another issue that happens when microservices sort of ramp up and we're scaling microservices is load balancing. It's essential to load balance microservices. Now, there's a whole definition and a whole site about how microservices are built, many sites actually. And a lot of how you build a microservice is to remove state from that microservice. So you want to give your microservice the ability to scale horizontally. Well, as you start to enter the world of scaling horizontally, you need to load balance your traffic between instances of microservices. So load balancing becomes really an essential operation as we're horizontally scaling different instances of these microservices. So as part and parcel of load balancing, we're going to need to understand that architecture, but not only understand it, we need to know how to implement it. So doing things like round robin load balancing, least weight, equal weighted, that kind of thing. We need to set up those sorts of approaches for load balancing. We also may need to do something like circuit breaking. So as applications become distributed, it's really important to prevent cascading failures. This is easier to do in a monolith because your business logic is so tightly tied together that you can sort of write in logic where if this error happens, then return, right? And your control flow of a request through to response can be broken by that simple return from the execution before another handler accepts that flow of traffic through the application. With microservices, that's not so often the case. So a microservice, each independent section may not be aware of failures in a prior section. So if bad data comes from a prior microservice as part of your flow of a request, your instance of a function here may not know that it was bad data from that prior microservice call. So a circuit breaking functionality needs to take place where you can then stop cascading failures in your application and basically have that return function that says, oh, sorry, our application's unavailable right now. So circuit breaking really prevents these cascading failures by shutting down portions of an application depending on certain criteria. And this could be things like 500 errors. This could be things like bad output, bad data, things like that. There's a whole bunch of different options, but circuit breaking really prevents those cascading failures. The other part that can be really important in service mesh is mutual authentication. Now, when we have a bunch of different services at play, it's really important to verify that both sides of a conversation are who they say they are. And that can really certainly have security implications because I want to know and ensure that there are no malicious actors, that everybody is who they say they are, so I'm talking in a secured manner with folks. But it also can be part of authorization authentication as well, where mutual TLS can say, I verify that this person is who they say they are, so they are allowed to take these actions, right? So mutual authentication, or MTLS, can really check a couple of boxes in that security thing. I can make sure that there is security between the conversation of multiple microservices, but then that authentication and authorization can also come into play and make sure that different folks are allowed to perform different actions. So let's jump in. All those things can be done without a service mesh. That's the kind of the part that's missing here. So routing and terminating traffic, load balancing, circuit breaking, MTLS, all these things can be done without using a service mesh. A service mesh, and I forgot to animate this, the service mesh infrastructuralizes these things. I've coined that word, that's my word, you have to use it now. The service mesh infrastructuralizes these different concepts. So instead of a developer having to independently, or a team of developers having to work together to implement routing, and traffic termination, to implement circuit breaking, to implement all these different things, a service mesh takes these components and makes them part of the underlying infrastructure layer. The goal then is that the application developer does not need to spend cycles on building these things for their microservices, that they need only to configure the mesh to provide this functionality for their microservices. So I've got a next slide here. This is a caveat, and this is that quote unquote who you ask part. There are exceptions to all the rules. So everything, this is the throw everything out the window that I've just said slide. There are exceptions to all rules. So don't believe that just because your application is getting bigger that it needs to be broken up. In other words, just because you have a monolith doesn't mean you need microservices. In that same vein, just because you have microservices doesn't mean you need a service mesh. Monoliths have existed for years, decades without issue. Microservices are great, and really this applies to service mesh as well. It's great if you meet the use case both technically and for your organization. So these are technologies to solve a problem. Like so many other technologies, they're an investment. They require care, they require feeding, they require talent devoted to working on these technologies. It's like bringing Kubernetes into an organization. It's like bringing a virtualization tech. It's like bringing a new software stack. It's like anything, right? You should not use any of these things just because this is shiny and pretty and I want to and mess around with it. That's fine if you want to do that at home. But if you want to use these, make sure that you meet the use case both technically and for your organization. So don't use this just because service mesh adds such another layer of complexity to your infrastructure that you may run into issues if your organization is not prepared for it. Okay, that's my last slide where I talk about like a teacher and take to the teacher's office here. So let's talk about service mesh concepts. There are a lot of service meshes out there. I've got a few on this slide. So we've got Istio, Linkerd. I don't know how to pronounce this. It's mesh or mesh because I never learned if traffic was traffic or trafic, but it's something. It's mesh or mesh, one of the two. There's Console and there's Kuma at least. Now these I, of course, lifted shamelessly from the CNCF landscape on service meshes, but there are a lot of other ones out there. Netflix has built some, Facebook I think has some, there's a whole ton of them out there. What we're going to be talking about in common concepts for the service mesh are things that most of these service meshes implement. So I say most in little stars or little quotation marks there because some of these service meshes may not have exactly every concept I'm about to share, but most of them implement the things that we're talking about. The first one is traffic management. So back on that microservice issue slide, traffic management is one of the big things that a service mesh brings to the table. With a service mesh, we're going to infrastructuralize, again, there's that word I've defined, we're going to infrastructuralize the concepts of routing, load balancing, and ingress. I've listed egress as a sometimes there because that's, again, one of those features that some meshes implement, some don't. But routing, in load balancing, ingress, these are concepts that almost all service meshes are going to implement. Egress is the concept of taking traffic and having it leave a mesh from a predetermined node. So having that as a functionality can allow you to make interesting security decisions like all traffic from this node should or should not be denied, right? It's mostly a firewall and sort of outside the mesh security concept. Most meshes are going to implement some level of security. So we're certainly going to have authentication and authorization probably as a part of a mesh. So making policy decisions based on who and why. And then most meshes are going to implement some sort of mutual security, which typically takes the form of MTLS. So verifying that both parties in a conversation are who they say they are. The client verifies the server and the server verifies the client. The third pillar of these common concepts is observability. So in a service mesh, we want the ability to monitor, to log, and to instrument our microservices. Now, again, there's that term infrastructuralize. We can monitor our applications outside of the mesh because we could just tie in, Prometheus exported metrics, or with logging, I can just grab standard out and standard error from some container running an application. That's fine. But observability infrastructuralizes this and says, okay, let's monitor our applications as part of the infrastructure. Let's instrument them and do distributed tracing across the infrastructure for all these different microservices. So if we break down traffic management, the first one is routing. So we want to make sure that we have the ability in a service mesh to get traffic from service A to service B. So this is the intra-mesh traffic. So we're going to make determinations on where to send the traffic. These will be routing decisions that we can base on things like HTTP headers, that we can base on things like TCP ports and TCP destinations and sources, that we can base on really any number of criteria. But the core is that we're sending the traffic from one place to another. So we're making a routing decision. Also part of traffic management is load balancing. So when I use a service mesh, I want to have the ability to do round robin, weighted, least traffic, different kinds of load balancing for our microservices. If a development team implemented those pieces of functionality independently, they may be into the application itself, integrating load balancing concepts, integrating health checks, things like that, where if we infrastructuralize these things, we can have the service mesh load balance for us. We can have the service mesh in the case of least traffic determine which instance in a microservice set is receiving the least amount of traffic. So I don't need to build these concepts into my application. The ingress resource, this would be bringing non-mesh traffic into the mesh. So this is how do I get requests from end users? How do I get traffic from outside external services into this mesh? We have this concept of ingress. If you've used Kubernetes, this is a very similar concept because there's the HTTP ingress in a lot of Kubernetes clusters, and that's bringing non-cluster traffic into the cluster. So it's the same kind of thing with the mesh. Ingress is bringing non-mesh traffic into the mesh. Then sometimes we also have the concept of egress. So we want to send traffic out from this mesh through predetermined nodes. And again, that's typically a security piece of functionality, but it also may be something for end user usability, right? Where let's say in our fantasy world that we have a service mesh that spans the globe. I may want to dedicate egress nodes for certain bits of traffic that send that traffic out through exit nodes that are close to my end user. So we can do like geolocated egress nodes where someone may send their traffic in, or a server may send its traffic in California, but it may egress the mesh in Germany close to a user, right? So that could be one of the use cases. Under security for a service mesh, auth is really the first concept. And this is, who are you? Who am I? Who is this thing? Usually it's service-based. So instead of it being, this is an independent person who's authenticated with the mesh, it's typically, this is a service. So auth takes the form of setting up that this service is who they say they are when they are communicating on the mesh. Now that ties directly into auth, our authorization piece, which is why, or what are they doing? So I guess it's kind of what and why. Again, this is usually service-based things. So now if we've completed our authentication and a service when talking on the mesh can say, I am service A, then the mesh can implement authorization and say, okay, service A, you're allowed to do X, Y, Z actions, right? So authentication is who are they? Authorization then in a service mesh, what and why. Mutual TLS then, services mutually verifying each other. Typically this happens via common CA, where the certificate that's issued for the client and the server is sourced to a common certificate authority. Thus, the server and the client have a common reference point to verify each other. That's kind of glossing over MTLS. That's a little deep for what we're doing today, but know that a lot of service meshes have that functionality. It's something worth exploring more. The final pillar that we're talking about is observability. Now this slide, with apologies to the whole observability industry, is going to kind of abuse the term. There's a great line from Honeycomb, their website. It's honeycomb.io, and they're an observability organization. And they say, in the world of software products and services, observability means you can answer any questions about what's happening on the inside of the system just by observing the outside of the system without having to ship new code to answer new questions. Observability is what we need our tools to deliver now that system complexity is outpacing our ability to predict what's going to break. That's a whole great paragraph. And I'm about to abuse the term observability, like I said again. Observability is a discipline unto itself. It is observing the outside of a system without adding anything new to that system. In this case, our observability in the terms of a service mesh is we can add in monitoring. So we're going to take a look at metrics about our traffic flows. We can monitor different incoming requests, outgoing requests, take a look at the return codes for those, and start building metrics about the performance of our application simply based on the traffic flow. So instead of monitoring application instances themselves, which you also should do, you now have the added ability to monitor the traffic flow. Under logging, we can capture traffic logs as a sampling of the traffic flow instead of app-based logging, or actually that instead should be in addition to. So capturing traffic logs now, we can capture when a request comes in, where's that request destined? What is the request ID if we wanted to do things like distributed tracing? What is the content of the request? So if something goes wrong in our application or in our microservice, we don't have to rely on that microservice working well enough to output a log. We can see that traffic arrived at that microservice and something went wrong. So it gives us sort of an enhanced visibility into the traffic flow. Finally, instrumentation is the third idea under observability. So we can perform distributed tracing that the service mesh will link together for us. Now what we're saying is in the service mesh, if I have a request that starts at one microservice and bounces to another and bounces to another and bounces to another, before returning to the end user, I can tie all of those requests across the mesh together and perform distributed tracing. So in a monolith, this would just typically be a normal tracing action, a normal debugging action where you would trace the flow through different functions that are being called in the app. There's direct handoffs of function calls and returns, and you can see all of that within your software. When you are working in a distributed application in a microservices world, it's not as easy because you cannot directly debug one application and have introspection into a completely different application when your microservice is finished executing. So having this ability to do distributed tracing and tie together these requests as they float around the mesh is a really powerful technology that really enhances your ability to know and really observe what's going on inside this mesh. Okay, pause for just 1 second. I'm gonna take a drink of coffee because I've been talking a lot. Okay, I'm sorry you had to hear that. Now, Istio concepts. So we spent all of our time so far talking about monoliths and microservices and what is a service mesh. Let's actually take a look at what is a service mesh, or what is Istio? How does Istio work? There's a bunch of core components to Istio. We're going to deploy them today. You're going to see them in action. The first section is the data plane in Istio. Istio is built, like a lot of different service meshes, on Envoy. Envoy is a proxy server. It is built independently of all these service meshes. So Istio didn't build Envoy. Envoy, I think, was actually built by Lyft, if I recall correctly. Envoy is a proxy server that is controlled in this instance by Istio. So Envoy is this proxy server runs as a sidecar to service containers in Kubernetes. So when you deploy a pod, Istio injects Envoy as a proxy into your deployed pods, and then Istio controls Envoy, which in turn helps you route traffic and so on. The control plane is collectively what controls Istio. So in this control plane here, we have Pilot. Pilot is coordinating service discovery, traffic management, and resiliency features. So Pilot is sort of one of the big core components of Istio, which helps you do all of the traffic and routing decisions within your mesh. If that handles all the traffic and routing, then Citadel handles the security. So Citadel is the security component for Istio that we use for mutual TLS, we use it for encryption, and credential and policy management. So Citadel is the control plane component responsible for implementing authn, authz, mutual TLS, things like that we've talked about so far. Galley is the final component of Istio's control plane, and that's a configuration translating, processing, and validating layer. The goal of Galley, and this is actually lifted directly from the Istio docs, the goal of Galley is to isolate Istio from the layer that it's running on, or from the infrastructure that it's running on. So Istio shouldn't have to be vulnerable to any particular misconfiguration in Kubernetes. Galley is going to ensure that any configuration passed into Istio by way of Kubernetes is valid, that configuration is translated into internal Istio configuration, where in Kubernetes it may just be, a YAML manifest or a custom resource definition, right? So Galley is a processing, validation, translating layer that isolates the underlying infrastructure isolates Istio rather from the underlying infrastructure and translates user configuration. The final component on this page that's not really an Istio component, but it's really valuable, is something called Kiali. So Kiali it's not a true Istio component. It's a third-party integration, and what it gives us is visibility for the management of Istio. So Kiali is an awesome tool that allows us to see traffic flows in Istio, so seeing what goes where. It allows us to configure different pieces of functionality to, track metrics if we have Prometheus and Grafana enabled. Kiali is just this great tool to manage Istio. Okay, so if those are the core components of Istio, what are the building blocks then? Well, the first building block is a virtual service. A virtual service is a thing, it is a concept, it is an item that defines how requests are routed to a service. So as you see in parentheses, what goes where. When we talk about virtual services, what I really want folks to focus on is the concept of virtual. An Istio virtual service is not a real service. So a real service, for example, there is something that answers requests. A virtual service, it's an abstraction that helps us define routing policies. We'll get to in a second how we actually get a request to a real service endpoint, but a virtual service is the first stop that abstractualizes, if I'm going to keep implementing new words today, abstractualizes a service. A destination rule then is what happens when we want to connect to a real service endpoint. So a destination rule defines what happens to requests when they arrive at a virtual service. So if we compare a destination rule to a virtual service, DRs are used against real service endpoints. So a destination rule is going to define things like load balancing, for instance, where if I send traffic to a virtual service, when that traffic arrives at a virtual service, the destination rule determines how that traffic is load balanced across actual real services that are providing, well, a service. It's kind of an overloaded term, but that are providing a function, right? So a destination rule is real implementation against real service endpoints, where a virtual service is how do I get traffic to a service. We have a third component, which is a gateway. A gateway manages how traffic enters, which is an ingress, and how traffic leaves or egresses the mesh. We have service entries. Service entries are a method or a thing by which you can add endpoints to the service mesh that exist outside the mesh. So this is important, especially, so I have an example there, databases. Let's say we're running inside of a service mesh, we have our microservice, and that microservice needs to call a database that, maybe it's a legacy database or a third party, it doesn't exist within our service mesh. The service entry functionality allows me to add endpoints to the service mesh so that my traffic can traverse the mesh and egress to that database without having to, well, not take advantage of any of the service mesh concepts. Finally, auth and auth policies. So these are who do what and where in a service mesh. So auth and auth in Istio is what allows us to define who can do what things in the Istio service mesh. We're going to take a look at BookInfo as an Istio example here. So I'll show that picture again. This is our microservice application that we've split up again. Remember, we went from a monolith to a microservice. We moved all of our functionality out into these microservices. BookInfo is Istio's sort of hello world example application. We're going to deploy BookInfo into Istio, and Istio itself will be deployed by Rancher. So as you're going to see here, Rancher makes it super easy to deploy Istio and manage its capabilities. If you've ever done the BookInfo deployment through Istio, you know that deploying Istio can be a little challenging. You know that deploying the BookInfo application and setting up all that stuff is typically done by manipulating YAML manifests and doing a bunch of kube control execution. Rancher has a bunch of helpers that are going to make this easier for us. One word of caution here is that this is not going to be an exhaustive demonstration of BookInfo. So I'm not going to go through any of the advanced concepts in BookInfo because there are a lot of different steps in the Istio documentation on how to set this up and use different pieces of Istio functionality. But really what this is helping us understand how Rancher implements Istio and how Rancher can help manage the Istio service mesh. So we're really only going to go through a couple of examples here. So it's not going to be an exhaustive demonstration. Okay, I've bored you enough with slides, so now it's time for a demo. As with all of my webinar demos, I'm going to need everybody to raise their right hand. So you're all sitting at home, all in quarantine, maybe enjoying a quarantini. That would be nice. Maybe I'll have one later. Raise your right hand and repeat after me. I, webinar attendee, do solemnly swear not to hold Eamon Bauman responsible for any mishaps that occur during this live demo. So help me Kubernetes. Okay, now that everybody has sworn that oath and it is legally binding, just don't ask a lawyer, we will actually go through and do our demo. So let me move my slides out of the way here. And we have our, let me log back in here, instance of Rancher. So let's go ahead and get this set up. So I'm going to click on my Eamon Istio Learning cluster here. And this is a sample cluster that I have set up. And this is running Kubernetes 117.4. It's a little EC2 application that I've deployed. Pretty straightforward, or a little EC2 cluster, I should say, that I've deployed. Pretty straightforward, not much to it. It's got one control plane, one etcd node, 4 worker nodes, as you can see here. Just a basic, simple cluster. What we're going to do now is deploy Istio into this cluster. So this is using Rancher 242, which is our latest release of Rancher. If I go under the tools dropdown here at the top, I can go to Istio. When I click on Istio, we have a bunch of different configuration options for deploying Istio into this cluster. First of all, we're going to need to enable monitoring. Monitoring will deploy as a Rancher feature Prometheus and Grafana. There was a great masterclass by some person last week on monitoring, so go ahead and check that out if you'd like to. What we're going to do here is enable monitoring. And then we have different configuration options for deploying the different components of Istio. I'm going to scroll down here to this ingress gateway. By default, ingress gateway is not turned on when deploying Istio through Rancher. So we're going to enable that. Now this cluster does not have the capability of setting up load balancers, so we're going to fall back to our node port functionality here, and we'll send HTTP and HTTPS traffic through on 31380 and 31390. So now that I've enabled that and set it to node port, we can hit enable here, and Rancher will go through and install Istio for us. So let's take a look and see what's happening. Jump to our cluster dropdown here, and we'll go to the system project. Inside the system project then, we can see, first of all, that the Cattle Prometheus namespace has been created and all of these monitoring components are being set up. So Prometheus and Grafana right off the bat are being deployed on my behalf just by clicking that enable for Istio functionality. So I'll wait for a second for those to deploy. But while those are deploying, I can scroll down and see there's an Istio system namespace that's been created here. So all the different Istio components like Citadel and Galley and Pilot, the things that we talked about, those are being deployed into this Istio-system namespace. So we'll give those a second to deploy, but once everything is completed, we will have a fully functional Istio service mesh installed into our cluster just by hitting enable. Pretty cool. So we'll wait for those to become healthy. Scroll up, let's take a look and make sure. I don't think that will go healthy because of a, let's say, oh no, it's just not ready, that's all. So we'll wait for that to become ready. Scroll down here, wait for this Istio piece to become ready. So then once that's set to go, we'll be able to deploy our BookInfo application and do some basic configuration steps. Cool, so I have 31380 and 31390 as my node ports that have been deployed here. And that should become ready in just a second, so we'll let that go. Now, let's jump back into our default, there it goes, jump back into our default project here. And the first thing we're going to need to do when we deploy the BookInfo application is make sure that our default namespace is ready for sidecar injection. It already has been, so I'm going to just disable it for the time being. What this takes the form of is in the background, in the Istio instructions, it asks you to label a namespace and you add Istio-injection enabled as a label to that namespace. Within Rancher, we've made that just a button click so you can enable Istio auto injection. So by doing so, we get a little sailboat icon that shows up there. So now our default namespace is ready for Istio to automatically inject sidecars. Now that we've done that, let's actually go and deploy our BookInfo application. So let me grab that workload here real quick. So go to Istio, and grab our BookInfo YAML. This is the only portion that I'm basically going to use kubectl for. So we'll open a kubectl. So I k get nodes. We've got our running Istio cluster. So let's k apply -f and then this manifest. So this is from Istio's actual instructions for installing BookInfo, and it's a YAML manifest that sets up the services and deployments for our BookInfo application. So I will apply -f this, and all these different things will get created. When I close, we can visualize in Rancher that all of my different microservices have been generated. So that's our picture of our microservices, right? Here's our product page functionality. Here's ratings, details, reviews, V1, V2, and V3. These are all microservices that together are providing our BookInfo application. So we'll wait for that to come up. Now, because we have deployed this using node port, I should be able to actually browse to that node port and see our product page. So let's go to our system cluster or system project here, scroll down into Istio, and we can see I've got my ingress gateway running on port 31380. So if I click on that, here's port 31380. Let's go to product page. And is this using HTTP? Because it should be. What cluster is that? That's running on that one. Why is it not loading 31380? 31380. That should be loading a thing. Interesting. Flash product page, come on. Let's take a look at the logs and see what's going on here. We have a few seconds to poke around. Bunch of warnings, bunch of things. Let's just kick it. We'll delete it. We'll kick it. We'll set up a new instance. Deploys on the same host. That was nice. So we'll copy that and see if that works. 380. Interesting. That should have worked on that. Maybe we can schedule it on a different node real quick. This is why I have everybody swear that live demos, they won't blame me for things that go wrong, because things that totally do go wrong. So we'll run all pods on a specific node. We'll run them on worker 3. Save that, and that'll restart that ingress gateway, run it on a completely different node. So we'll copy that. So our node port 31380 doesn't work. Excellent. What about 31390? What about HTTPS? Let's see if that works. HTTPS. Interesting. Totally doesn't work. That's not cool. Give me just 1 second. We'll keep messing with this. May have to just redeploy a couple things in Istio here to get this working. Let's take a look at our services here. So under workloads, we'll go to service discovery, Istio ingress gateway, 3138. Let me refresh that. Hard refresh and see if that node port updated. Still on that same endpoint. Weird. Okay. I am going to redeploy that workload. So let's check and redeploy, see if that updates that node port functionality. Let that upgrade. Ooh, this might be a CPU utilization thing. Interesting. Uh-oh, that is not good. Let's see if we can jump into a different cluster that has Istio enabled. I think we have another one as a helper here. So EC2 cluster, let's take a look. Istio is enabled. Okay, cool. Let's go to our system project. I think we can still get away with doing this here. System project, that is not deployed. Darn, that is really unfortunate. Let's see if we can fix this one then. Istio learning, back onto the system. Ingress gateway. Still a bunch of failed pods. Okay, let's delete those. Get rid of all that garbage. See if we can scale that down and get those running. Darn, this was working a little bit ago. It's unfortunate. Let me see if there's any other workloads that are using too much CPU. Okay, that looks right. Back under systems, or anything that's taking up too much. I really would like to get this to work for you folks here. It must just be a bad cluster. I was messing around with it a bunch today. I must, those are going away. We have that one running. Okay, where's that running on? Let's change our node scheduling and allow it to float here. Pick nodes, scheduling rules, save that. We'll allow it to float somewhere else and see if we can get this working. Okay, that one's running on that IP, so let's go there. Colon 31380. Still not loading. Make sure I have the right port. Maybe I'm using the wrong port here. Tools, Istio, scroll down, ingress gateway, 31380. Yep, that should be the right port. / product page. No go. Interesting. That is unfortunate. I wish that was working. Let's disable Istio. I'm going to try one last ditch effort to get this working. So let's disable Istio and monitoring, and we'll redeploy here real quick. So I'd love to be able to show you folks this. This is a cool demo. Let's let everything undeploy here, remove that Istio gateway, go into our default project. Our workloads can stay deployed, that's totally fine. Our namespace can stay with the injection, that's totally fine. We'll redeploy Istio here. So removing that. Okay, so that namespace should be gone now, almost. delete that namespace. Get rid of the finalizer on that namespace. Oh, okay, edit namespace istio-system. Oh, gone, perfect. Okay, let's redeploy. Istio, tools, Istio. We're gonna go down here, ingress gateway, enable that, use node port. Let's change the node port, 33380. All right, derp. 32080, cool. 32090. Okay, let's try that. We'll enable those different ports. We will go back and let Istio redeploy into our system project. Resources and workloads, scroll down here and wait for that to deploy. There's monitoring, Cal Prometheus, and we should see Istio show up here in a second. Apps. You can see under apps, there's Istio being deployed. There's cluster monitoring being deployed. So they actually are just installed as Helm chart applications. Back under workloads, there's Istio coming up. So we'll wait for the ingress gateway to come up and all that related tooling. When we go to that URL, we should see our product page. So the ingress gateway should take care of routing that traffic to our page. So we'll wait for that to get set up. If I go back under default here, we've got details, we've got our project page, we've got all that stuff. I'm gonna redeploy this stuff real quick. So we will use our URL to delete and redeploy. So K delete -f, and there's our URL. We'll get rid of all those deployments and services so that we can redeploy fresh. So we'll wait for Istio to come back up and be healthy. Back under system. Okay, looks like Istio's up. If I go to 32080, I still get that, but let's still deploy those workloads and see if that makes a difference. Maybe I deployed too soon. Okay, so let's deploy this. So K apply -f and then our BookInfo.yaml. We'll deploy this. So now that we've deployed that, we should be able to reach our instance. So we've got product page running here. Okay, if I click on the product page, we see Istio. There's the proxy that's been injected, so that sidecar injection has occurred as expected. If I go under my dropdown, we're in the system project here. Let's grab 32080. Can I go to /product page? No, that is disappointing. I apologize, everyone. That had been working the 7 times I tried it prior to just now, but unfortunately it didn't. Let me walk you through what we would have been able to do. So if that had worked, what I would have walked you through here is back under the default project, we would have deployed our workloads here, as you can see. So we have our BookInfo application. When BookInfo is successfully deployed, you get this web interface that shows you information about the book. It shows you reviews, it shows you ratings, details, all that kind of stuff. What the BookInfo tutorial has you do through the Istio instructions is set up, the first thing is set up traffic management. So we configure request routing to say, when someone logs into the BookInfo application, show them rating information. When they don't log into it, don't show them rating information. What we can do is under the resources dropdown in Istio, we can configure destination rules and virtual services to set these things up there. No virtual cert, that's weird. I wonder if that's what's going on. Hang on one second. Let's deploy the virtual services. Could that be it? I thought they deployed with that. Okay, resources, workloads. If this works, I'm gonna kick myself. Scroll down. Am I in the right cluster? Yes, system, 32080, TCP, product page. I was hoping that was the case. Okay, so anyways, back in the default project under Istio, you would be able to manage creating these virtual services. So again, the virtual service is where does, or let's define abstractly a service. So we have our 4 services: details, product page, ratings, and reviews. And while I created those through YAML just there, we can add a virtual service using Rancher's interface. So I can define in my virtual service, well, let's pick a host to send this traffic to, and now we can make routing rules based on incoming headers or the method or the URI or even the scheme here if I want to send traffic to different subsets like V1, V2, V3 of this rating service. So I can configure that application. So now under destination rules, I can change and add things about destination rules, which allow me to define where I want to send the traffic to a particular service endpoint. So if I want to say that I want to define a subset, there's my V1 as defined in the virtual service, how do I want that traffic to end up at a particular destination? Well, under the ratings here, I can add subsets and define different versions for this destination rule. I can also add gateways. So if I want to add an ingress gateway here or an egress gateway, I have that option through Istio's functionality in Rancher here. Traffic metrics and traffic graphs are functionality that's imported from Kiali. So were this to be a healthy cluster, and again, I apologize, I wish it were this to be a healthy cluster, the metrics and traffic graphs would show up here, imported from Kiali, so we could see those pieces of functionality. So here's that graph showing up. There's my different services that I've deployed. So there's, if I scroll in, there's my details, virtual service, my product page, ratings and reviews, all that kind of thing. Those show up here inside Rancher, so you don't need to necessarily go out to that Istio, or excuse me, that Kiali instance to troubleshoot those things. Okay, since there's not a lot else I can do here without Istio working, I'm going to jump back to the slides. Again, I apologize, folks. I wish that had worked in it, and it did, you know, the 300 times I've tried this before. So I'll run that. Wrap up and summary. So we deployed Istio using Rancher. We certainly did do that. So in the cluster, tools and Istio at the cluster level is how you would deploy Istio into your Kubernetes cluster. Rancher will deploy and manage those Istio components for us. So we installed Istio as a Helm chart under that system project, and now we can configure basic Istio resources using Rancher. So as you can see under the resources and Istio dropdown, Rancher has manageability of gateways, destination rules, and virtual services. So the first portion of the BookInfo tutorial within Istio is deploying gateways, destination rules, and virtual services. And were our demo, and was our demo had to have worked, we would have been able to set up those different resources directly from within Rancher. Rancher then will import traffic graphs and metrics from Kiali so we can visualize those things. Advanced topics that we didn't get to cover, well, really any topics we didn't get to cover. Circuit breaking is something that Istio offers. We would have been able to stop traffic or even redirect it when certain situations occurred. So this would have been things like if we had too many 500 errors that were showing up over a period of time, if there was a specific response from some kind of health check on a service, something like that, we can define different criteria by which we would like to break the circuit. Istio also gives us the ability to do fault injection. So if I wanted to inject faults into the traffic flow to troubleshoot and prepare for any issues should they happen, Istio allows us to do that. So if I want to say, hey, let's test what happens when 50% of my requests yield 500 errors, Istio will inject those 500 errors and we can test what happens when our application fails. Then another thing we wouldn't have gotten a chance to look at would have been observability. So distributed tracing via Jaeger would help us uncover complex service-to-service issues. And again, that's that functionality where I'd be able to see a request as it flows between different services in my mesh and be able to trace that request from point A to point B. Finally, mutual TLS, we'd be able to verify both client and server are who they say they are. So where would we have gone? Would the demo have worked? Istio has a great set of documentation on their website, so istio.io, that's where I've spent a bunch of time doing more research and learning about it. There are plenty of other service meshes in this category. So if you check out the CNCF landscape, you can see all the different service meshes that CNCF has on their, well, on their landscape. And then finally, Rancher's Istio functionality is available in our documentation. So it's just rancher.com/docs. And then on that website, if you go into our Rancher 2.x documentation and look under the cluster admin section, you can find information on Istio. For, oops, didn't mean to click on that. For Rancher itself then, let me go back here. Where do you want to learn more and get more help? With the Rancher user Slack. So check out slack.rancher.io. I'm on there, so if you want to come badger me about this not working, you're more than welcome to find me and yell at me. Rancher forums. This is one of the most active forums I have seen in the technological community, at least in the cloud native community. We are constantly posting help topics, issue resolution with clients, with open source users, new product announcements, forums, features, all that kind of thing. Those are available, forums.rancher.com. Finally, we have a GitHub repo, github.com/rancher/rancher. That is where all of our application code lives. Everything the Rancher does is completely open source. So please come check out our code, file issues, file requests for assistance, anything you want. Check it out, github.com/rancher/rancher. So thank you. Again, I apologize. I wish that demo had gone as prepared. Maybe I'll put a video together for the next time I do this. But find me on GitHub if you want. I'm eBauman on GitHub. You can find me on Twitter at AemonB, or don't find me in real life. And I mean that even without the quarantine. So thank you. I guess, Matt, I'll answer
Yeah,
questions if there are any.
awesome. Yeah, there are a lot of questions, Eamon, and thank you so much for going through all of that. It's a bummer that that demo didn't work, but that's life. So it's live. Proves that it is live for everyone.
Yep.
So and thanks Jason and Sheldon for answering so many questions in the chat. They've been awesome. So okay, let's start going through here. Let's see. Let's do. This one is from Ju, who says, "What do we know? What do we need to know that we should deploy and use Istio in our microservice environments? How do we know we need service mesh in our system?"
You're typically going to know you need service mesh when you start running into either repeated work or issues with doing sort of the things that I listed on that. So let me actually scroll up and find where's that slide here. We have a great slide. So where does service mesh come in? Let me get my notes out of the way. So if you're starting to, as you deploy your service mesh, do a bunch of repeated work for setting up load balancing, doing a bunch of repeated work for routing and terminating traffic, really that there's a lot of toil, and not meaningful work being done, a service mesh can really help take care of all that so you don't have to do it yourselves. Another thing is where maybe you're starting to have issues with doing this, and issues is sort of this broad term because it could mean really any problem top to bottom, right? But if, like for instance, you're having issues bringing up new devs and getting them used to the idea of setting up routing and terminating traffic, maybe take that out of your new developer training and make it part of the infrastructure. Or if you're really running into a challenge with how to appropriately implement something like circuit breaking in your application or mutual authentication, instead of having to actually do that work yourselves at scale, again, let the service mesh handle that. Now, this is all fine stuff, I think, to learn and to implement at a small scale, right? Like if you've distributed your monolith and you've broken it up into microservices, you're going to do a lot of this by hand, and that's totally fine because that may be all you need to do, right? Like if you have one monolith and you break it up into microservices and you implement routing and terminating, you implement circuit breaking, you implement all this stuff independently, and then you don't have to do it again. You just scale your application. You may not necessarily need a service mesh, right? Like it adds so much more overhead for work that you've already done. But if you're adding new microservices and you're constantly sort of reinventing the wheel every time a microservice comes out, or you're doing this work over and over again, that's where a service mesh can really help.
Awesome. And a kind of a follow-up question. I think you sort of answered this, but just to answer it directly. So Oladapo and several others have asked, he basically says, can't Kubernetes do the things service mesh solves, like load balancing using services and self-signed certificates?
It can, yes. And in fact, there's a great presentation by Tim Hawken who says that Kubernetes is the OG or the original service mesh, right? There are a lot of these pieces of functionality that already exist within Kubernetes. But there's also a lot of pieces that don't exist within Kubernetes. So like circuit breaking is not a functionality that Kubernetes offers out of the box, while it may offer load balancing and decisions like that. Advanced traffic routing doesn't necessarily exist within Kubernetes because with like HTTP traffic, for instance, I have ingress options for sending my traffic based on a host or a path name. But when I'm inside my mesh or inside my cluster, right, I don't necessarily have that same option unless I'm integrating it directly into the application. So yes, Kubernetes does do a lot of this stuff, but it also doesn't do a lot of this stuff too.
Cool. Okay, makes sense. All right. More questions on implementing service mesh when you decide that you do want to use it. So this is from Sammy, who asks, should we enter the service mesh directly via the ingress controller, or is it more recommended to enter the cluster using ingress like Nginx en route to the Istio ingress?
I've seen it done both ways. Honestly, in my opinion, I would just do it on the service mesh ingress and hop on the mesh as quick as possible, because you sort of get all the features of the mesh, like the observability and the logging, the second you get on there. And if something's going wrong on a layer before that mesh, you'll lose those troubleshooting features. It also just helps from a simplicity sake, where if as soon as I enter the cluster, I'm also entering the mesh, I don't have other things to troubleshoot, I don't have other things to worry about. You can also declutterify, and this is again inventing a word, declutterify your ingress resources just by allowing the service mesh ingress to take care of it, where you may have other applications using ingress that are not service mesh aware. So you can sort of simplify that configuration. It's a little hand wavy there, but I would try and get the traffic onto the mesh as quick as possible, but everybody's going to have different needs.
Yep, makes sense. Thank you. Okay, here's the next one. And a few people have asked this. What's your opinion if you could compare and contrast Istio versus Linkerd?
Istio is more mature and Linkerd is lighter weight. So Istio has a lot of features that Linkerd doesn't necessarily have yet. So Linkerd is going to be newer, but Linkerd is also a lighter weight implementation of a service mesh. It's the reason we used it for our Rio application, because Rio itself was designed to be a lightweight thing, and Istio has a lot of components that need to be installed in order to make Istio work, where Linkerd doesn't necessarily have the concepts of Pilot and Citadel and Galley and all those things. It's just a lighter weight, like a Linkerd basically that runs. In terms of feature completeness, Linkerd is going to give you sort of everything that I showed on this common concepts, maybe minus like egress and MTLS, though I don't remember if Linkerd has that. It has most of everything else here. Istio has some other advanced concepts that aren't listed on this page, and the Istio docs have all those details. So it really is just a maturity versus lightweight comparison at this point, though now in each one of those favor, Istio is being rewritten for Istio 2, which they're going in a much more lightweight direction. I think they're actually taking the Istio components and monolithicizing them. Again, I keep inventing words today. They're sort of breaking up their distributed approach for their service mesh, and they're making Istio D as a single monolith, which will hopefully be able to take advantage of a bunch of performance improvements. And Linkerd, because of the velocity of that software, is going to certainly mature rapidly as time goes on and become more feature complete. So I think you're going to have answers to both of those comparison points, where it should be an interesting horse race kind of in the next year or so to see who's going to be better at what.
Makes sense. Okay, cool. Thank you. All right, here's next one. And I'm probably going to butcher your name. I'm sorry. You asked us a while ago. This is from Jehoshaphat, who says, what's the performance impact if we use Istio MTLS with authorization and authentication?
I'm going to be perfectly honest and say that I don't know. I have not implemented that in one of my applications. I would imagine that it's non-trivial. Mainly, I'm saying that based on the fact that Istio itself, that impact is non-trivial. I don't know the specific performance implications of enabling MTLS, though I would be very interested to see graphs and comparisons, against some sort of baseline to determine what that is. So unfortunately, I don't have a direct answer for you, but I'm going to kind of hand wave and say non-trivial, but I'd like to see more.
Okay, cool. Sort of related, this is from Nicholas, who asks, and this is a kind of a Kubernetes compute resourcing question. He says, do we see minimal footprint in terms of compute utilization relative to a non-Istio deployment, versus an Istio deployment?
Can you read the question to me one more time? I'm sorry, I think I lost the train.
Yeah, no problem. And there's other people who have asked a similar question, I think, so I might try to find another phrasing. But he says, do we see minimal footprint in terms of compute utilization for a non-Istio versus Istio deployment? I think he's asking, like, what is the compute utilization of using Istio versus not using Istio?
Each one of the components has a document, I think, to their compute utilization. I'm going to say it's heavy, and I'll actually show you inside Rancher. So if I go to the Istio Learning and I go under Istio here, like if I look at Pilot, we've got like 1 CPU and 4 gigs of RAM as a limitation for Pilot. And these limitations, I think, were really born out of a moderate usage level. So I don't have an exact minimal amount, but just to say that we're limiting it 1 by 4, which is almost the size of like a T2.small, right? I think it's like 2x4 is a T2.small. So Pilot takes up a lot of resources. Mixer is sort of an older technology. They've deprecated the use of it, I think, in favor of Galley. But the Mixer telemetry here, we're limiting at 4x4. So these components are actually really heavy. And if we deploy all these, and let's say they use up to their limit, that we're in a heavy configured thing, we've got a 1x4 of Pilot, a 4x4 of Mixer, distributed tracing, we've got a 1/2x1, and then I didn't even talk about, I don't think Galley's listed in there. So almost we're talking probably about 5 or 6 CPU by what I'm guessing would be by 5 or 6 gigs of RAM, which in bigger clusters, probably not the end of the world, but then again, in bigger clusters, you're gonna see scaling up of those components. So really take a look at what Istio's documentation has in terms of scaling, but it's gonna be heavier than you think.
Awesome. Okay, very helpful. And so this is, I think you might have just answered this with 5 to 6 gigs, but David says, I've been testing monitoring Istio and logging on my clusters, but I keep running into memory or CPU limits. What is the recommended cluster size, gig size?
I will say that that largely depends on other workloads. If you're installing just monitoring and just Istio into the cluster, I think that what I've developed here is probably the baseline because we've had issues with this one. And this is a 4-node, each with 2x8 that we've been running into pretty heavy utilization on. So you could maybe go a little smaller than this. I could maybe do a 3-node of 2x8. These are all T2.larges. You could maybe do a 3-node, of 2x8 nodes here, but I certainly wouldn't go much smaller than that. So you could probably establish a pretty simple baseline of worker nodes as at least 6 core and what's 3 times 8, 24? Yeah, 24 gigs of RAM, which is pretty heavy when you think about it.
Yeah, cool. Thank you. Okay, there's several more questions, and I know we have gone over kind of our scheduled timing. And are you able to stay on a few more minutes to answer
A
a
couple
couple
more
more?
minutes. I can do that.
Okay, cool. Okay, cool. Okay, we'll wrap up. Let's just find a couple more. This last one, this is from Jew, who says, can we run Elasticsearch in Istio in service mesh, Istio service mesh?
I don't see why not, though that's such an Elasticsearch specific question. I'm not qualified to answer it. My understanding is that you would be able to, so long as your log collectors are able to hop onto the service mesh and insert their traffic into Elasticsearch. So as long as that traffic can occur, because Elasticsearch, from my understanding, speaks mostly HTTP for the log transiting, that it should work. But again, your mileage may vary, and I am far from knowledgeable about Elasticsearch.
Okay, cool, awesome. All right, here we'll have this be the last question, Eamon. This is from, since you have to go, this is from Albert, who says, I'm still a bit lost on the application example itself. What do I do and how do I route to the service? Is there anything to do on the application code itself?
Yes, so let me go back to my screen here. And that's something I definitely could have explained a little better. So splitting up the monolith, we've got this picture over here on the right. What would happen typically in this case is that your microservice for the product page would, when broken out from the monolith, be basically rewritten from the ground up. So you'd probably reuse some of the code and certainly the logic from the product page, but you would rewrite it so that instead of having a direct dependency on calling like a details function, like maybe you have a details class that has a bunch of different things in it, and there's a method you can call on some details class, and the product page calls that method to get information. Instead, you would have the product page call out externally to some sort of details microservice. And this is where the mesh really helps. And I think this is great. This is what I should change these slides up to explain a bit more. The product page microservice should call out to some generic detail service. It shouldn't have any idea of the existence of a specific microservice. It should just know that somewhere out there, being outside of itself, somewhere externally to the product page, there exists a details service. So the product page simply queries service at some predefined API endpoint. Now that may be gRPC, that could be just some kind of REST API, whatever you want, but the product page makes an external network call to get something from a detail service. So the act of making that call is what service mesh concerns itself with, where the mesh will be able to say, okay, a call from the product page to the detail service should go to this virtual service in terms of Istio, or we're going to be routing some amount of that network traffic from the product page to the details service to a new instance of our service. So that would be where like the traffic management component would come in. So yeah, basically every microservice here should be making network calls to other microservices, depending, completely on protocol and things, to retrieve the information. Now that would be compared in a monolith to making like a direct method or a function call in a different area of that monolith application code.
Okay, awesome. Thank you. Okay, I think since we're over time, we'll end it there. There are some more questions in the chat. We've gotten to many of them. If you didn't get your question answered, then please join us on the user Slack on the masterclass channel, and we can follow up with you afterward. But I think we will leave it there. Is there anything else you want to leave us with, Eamon, before we wrap up?
Other than to say, go out, install Rancher on your own and try this. Obviously the live demo failed and that wasn't great, but it does work. It did work for me last night. It did work for me this weekend. So please go through, try and set up the BookInfo tutorial on Istio. Don't let this failure shy you away from the functionality that we have. This was just some sort of transient thing that got messed up. So I really encourage everybody, go try this on your own. You're gonna have a cool experience.
Awesome. Yeah, I agree. And we do a intro to Kubernetes and Rancher class every Thursday. So this is a great opportunity to join one of those. We'll talk a little bit more about service mesh there. So that's a good next step. Next week also is the 2.4 online meetup with a walkthrough. Darren Shepard, our Chief Technology Officer, is going to be on there, and Shannon Williams, is President of Rancher, will be on there, both kind of leading the way, explaining 2.0. 2.4. There were quite a few questions about whether 2.4 is production ready and all that, and that is the place to get those questions answered, since 2.4 just dropped this past week. Otherwise, thank you all so much. Eamon, thank you for your hard work, really appreciate it. And Jason and Sheldon, great job answering questions in the chat too, so we could save Eamon's voice box a little bit here. And we will be posting the recording on YouTube and sending out the slides to everyone, so don't worry, you'll get all of that later on today. All right, everybody, have a great rest of your week. Talk to y'all soon. Thanks, Eamon.
Thanks, everyone. Bye now.